Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I just appreciate you watching. This week we're continuing right along. It seems like things are moving really, really fast, right? It was only yesterday, it seems like, that the semester was just starting, and now we are in the midst of Module 3. And as we are in the midst of Module 3, we are discussing inputs, basically. Inputs and outputs. That's the big point of this module. And one of the really big things that I like about inputs is just this idea that I can take a program that is mostly static, right? That is mostly just numbers and letters and things put into my program, and then I can on the output get a result. I can take this program that is static and turn it into something that's more dynamic, right? That can change based on the way that my user wants to work with it. So somebody with programming knowledge doesn't necessarily have to interact with the program. The user, whoever that might be, can enter in new data every time they work with the program and get a good result. And so that's to me is the huge thing about being able to take an input, regardless of where that input is from. Right? We talk about it in terms of scanner for this module. When we get towards the end of the course, we'll be doing GUIs and we'll be examining things with GUIs at that point. We might do a little brief example about how to read from a file and things like that in Java a little later on in the semester as well. It's not something that we typically really care a lot about in this particular class, but we might do a little something with it later on. Who knows? We'll see. So we're talking about systems and scanners here. That's the title of this lecture. Because one of the things that we've noticed is that we've actually already been using the system class. Right? We've been using the system class to utilize certain methods, but we haven't really talked about it. right? Because everything that we've done so far, we've printed it out to the console with system.out.println. And if you look at that word system begins with an uppercase S. And as we're working in programming languages and we're working with Java, we'll see that our classes always begin with an uppercase letter, regardless of what the class is, right? Like if we look at our own replets and the things that we use there, we see the class main with a big uppercase M starting the word main. So whenever we see an uppercase letter starting at the beginning of the word in a Java program, we can assume that that relates to a class in some form or fashion. And so in this particular instance, we are extending our use of our system class. Right? Our system class allows us to interact with a system. We're getting inputs, or we're giving outputs, and we're taking inputs, and we're running it through the system for a process. So our system class lets us take advantage of a system. And it really, that's kind of what helps us work with things, right? Like, so if we look at the system class just in general, right? System is the class, we just mentioned that provides methods related to the system. And so for our purposes, right, we can run system dot something, and that dot something is a method that is a part of that class that runs, right? So as I mentioned, we've been using system.out. And this is a particular method that allows us to display the output, right? We've been using this. We should know this by now. But check this out, right? This is an interesting thing for us to kind of deal with. Let's get into a little replet here and do a little bit of work with it. So I'm going to create a new Java replet here. So we're used to seeing system.out.println, and in between our parentheses here, we have something that we want to print. For example, here we have hello world, right? And when we hit run here, it prints hello world out to our console. But what if we printed out the result of system.out? Right? We said this is a method, and a method is like a function. It's a sequence of instructions that do a particular thing, right? So if we take system.out and put it right there, and we run this now, we get a really interesting result here. java.io.printstream at 494.76.842. For java.io.printstream and a location here. So what this is, right? What a print stream is, and we can see print stream here starts with an uppercase letter. So as we just said, if it starts with an uppercase letter, that probably means that it is a class. So print stream is a class. Print stream adds some functionality to our output stream. Right? So it just gives us the ability to kind of print out data to our output stream. And so what we have here is we have the method that we use and what is essentially the location in memory where this object is living. Right, so we have a class object here and a location in memory where this class object is living. So every time we run system.out.println, it creates a new print stream object. It puts it in a new location. Right, if we run this exact same, like if we copy this line and paste it again, we see here we get the same memory location because it's the same product, but it's the same thing, but a little bit, we just called it twice, right? So we haven't created a new object here. It's just the location in memory where it's living. So it is a little different than what we might kind of talk about with objects in general. That's neither here nor there, really, right? So if we were to look and we were kind of to examine, well, what did we exactly just see here, right? What did we just see here? We got that print stream. Java IO package has a method in it called print stream. Functionality to another output stream. The ability to print representations of the output stream. And those numbers after the @ symbol that we saw are just an address of the location of the system.out object in memory, represented as a hexadecimal base 16 number. So that kind of gives us an example of a class that we've been using in general and kind of how that works. Right? A class is another, we can basically think of it as another file that exists inside of Java that has specific methods, that has specific locations in memory, that does different things to allow us to extend what we can do with Java. And this allows us to get this one in particular allows us to get our outputs. But I said that today we were going to be working with inputs, right? And for inputs, we in particular use the scanner class. So scanner is a class that provides methods for inputting words, numbers, other data. In our program from externally, right? It allows us to use the system in order to be able to add data to our program. That's the big thing, right? We can use the system to add data to our program. Now, one of the things that we learn here is that in order to use the scanner class, we have to import it first. Java's portable. It allows us to, kind of do a lot of things by just using the Java libraries that are included in the main Java code base. But we don't necessarily need everything that's in the code base all the time, right? So we don't necessarily want to use something or have something called in our code or include a library with our code unless we're actively using it or unless we're going to use it. Right? So that's why we import the scanner class. The last couple of weeks, we haven't needed the scanner class. So there's been no need to import it. But now we need it. We're going to be taking inputs. And so we can work with it from here to do our thing. So let's do a little example here, just to show how scanner works, and we'll do a little bit of programming and a little more examples as we kind of progress today. Right, so the first thing that I need to do here is I need to take an import scanner, and I need to import scanner at its location. So as it said on the last slide, right, scanner is a part of the java.util library, right? It's a Java utility. So when we import it from there. So I am going to import at the very top of my screen before my class main. I am going to import java.util.scanner, making the point to kind of show you all that scanner here is uppercase S, everything else is lowercase. Scanner is representative of the class. And so now, whenever I reference scanner in my program, my compiler knows exactly what I mean, right? If I didn't include this import statement, my compiler wouldn't have the first idea of what I was talking about. It would be super confused, right? Like we could even see that happen. Let's go ahead and comment this out. If we comment this out and we add a reference to scanner by, let's say, creating our scanner object here. So we'd say scanner n equals new scanner on system.in. We immediately get red squiggles under the words scanner in this line of code here, because it doesn't know what I'm talking about when I say scanner here, right? Because since this is commented out, it doesn't exist in the program. Now, when I bring this back in, we see those red lines go away. We see a little yellow line go under the word in. Now, something to point out about the word in here, because it's something that confuses people a lot of times, right? This is just basically a variable name, right? So I'm just creating a variable that is a scanner typed variable and creating my new object inside of this variable. What will confuse people a lot of times is that this variable name, it can be anything, right? But oftentimes what you see in code is people use the word in for input, right? And people get that confused with the word in on system.in. This name can be whatever we want it to be, right? It's just a variable name. And we said when we were talking about variables that are variable names, they have a set of rules that they have to follow, but they can be pretty much whatever we want them to be. This side, on the other hand, which we'll draw pink arrows for that one, this reference to the term in mirrors the term out when we use system.out.println. Right, so this is on system.in instead of system.out. So it is a system-based input, which is our console. It's this location here where we are creating our scanner to listen to, or to listen for, I should say, input. So if we were to simply print system.out.println in here. See if it lets me do that. We get that same kind of thing where we have an object here that was created and it's sort of waiting on us to add to it in memory. Right, and this term here could be anything. It could be in, it could simply be the letter I, it could be the entire word input, it could be treehouse for all we care. just so long as everything else here is the same. That's creating our scanner object. And in general, we only need one scanner object per program. We can use the same scanner object multiple times to get multiple text. So for example here, just for our purposes, let's change this back to, let's just use the letter I, okay? We'll use the letter I. And let's say I want to ask somebody their name. Let's say I want to ask somebody their name. And so one of the first things that I'd want to do is I'd want to print something to the console that is performing that task, right, in terms of asking somebody their name. I couldn't just put my scanner item in here because then it would seem like my program freezes up and your user might not know what you wanted to do. So you want to make sure that you're giving your user some kind of instruction here in terms of what they're supposed to do. And I will use system.out.print here instead of system.out.println, because if I use .print, then whatever comes after the string that I put into .print here, for example, what is your name? I can put a colon and a space at the end of that. And it'll be on the same line as the object that is getting the value from my console. So in this instance, right, I'm going to put something here that can take in my input, right? I have to have some container to be able to hold the value that my user puts in the console, right? So I need a variable. So in this case, we're asking what somebody's name is. And when we're asking what somebody's name is, that is a string, right? And if your name is an integer or something like that, that might be a bit of a bigger problem, right? So we're dealing with a string here. We might put something like string username. And set that equal to the name of our scanner object, which in this case is I, dot next line. And next line is a method, so it ends in parentheses. And we'll throw our semicolon after that. So let's talk about this next line here for a minute. This next line, if you're familiar with Python at all, next line is basically treated as a print statement, right? Whatever the user enters can be entered with a next line. And so typically we use this for strings, right? And if I remember correctly, it actually treats everything like a string. So it should be used with a string variable here. If we have different data types, we use different ones of these. If we have an integer, we use next int. If we have a double, we use next double. And so on and so forth, right? But for strings, we use next line. So now we have the ability to ask our user a question, right? We're just using a simple print statement with that. This will pause our program and wait on our user to enter this value so it can be stored inside of our username variable. And then we can just print it out. So system.out.println hello, and concatenate that with the value of username. And so this allows us to get an input from a user and then greet them in kind. Right, so if we run this, it asks us, what is your name? I can put in something like Mr. Ramsey. and it replies, hello, Mr. Ramsey. If I enter some kind of integer here, it's going to give me that integer back, but that integer is not going to be something that I can do math with because it's not being brought back as an integer, it's being brought back as a string. Right, remember that a string is just a string of characters. So it could literally be anything. Now we can do some typecasting and things of that nature, which we'll talk about later on, to be able to convert that into something that we do math with, but again, we don't have to worry about that here. Because we have different means of being able to pull things in. I'm going to leave my scanner here, since we need a scanner object, but I'll just comment the rest of this stuff out here. Just so we can kind of keep working on some stuff here. In the future, we won't have to worry about that because we'll just use multiple methods. But for the time being, we're still doing everything in main, right? So let's just do some practice here that's with numbers, right? So let's just do basic addition, right? So I'm going to create an integer variable, int. We'll call the first one num1, and we'll set it equal to the input from our scanner. So it'll be i.next int, like so. Now, ideally, we would have wanted to add a message, say here, system.out.print, enter a whole number. Right, then our program's going to pause. We can actually test this if we just add a little system.out.println num1. We can actually do a little bit of intermittent testing here just to make sure this will work. And we can see it pauses. It waits on me to enter a number like 45, and it gives me back 45. Now you might be wondering, I'm working with ints and next int here. What if I enter something that's not an integer? What if I enter something that's, say, a string? It throws a fit. Right? It errors out and crashes my program. Later on, we'll talk about how to check for these things. We need conditionals before we get to that point. So we have to wait until we add conditionals to our toolbox. So for the time being, we're just going to assume that our users are experts at being able to use the software that we provide them. So we're not going to worry about data validation. We're just going to do the thing. If we enter, say, a floating point number, likewise, it's going to have a fit and crash. So if we are working with integers, we want to make sure that we're testing with integers every single time. So now that we see that that works the way that it's intended, we can delete that output. And we can add another whole number, system.out.print, enter another whole number. And we use one scanner to get our data. We're just getting a different input, right? That's why we store them in variables. So we're using the same location in system to be able to get data. Just we in turn store it to a different variable. So we'd say int num2 equals i.next int. And so now we have two integer variables that we can do anything that we want with. So for example, we can say system.out.print line num1 concatenated with plus concatenated with num2 concatenated with equals concatenated with num1 plus num2 evaluated inside of quotes, or inside of parentheses rather. All right, so now we've just created a highly rudimentary adding machine. All right, so I can take it, I can give it two whole numbers, enter a whole number, say 15, enter another whole number, say 30, and it tells me 15 plus 30 equals 45. Right, highly rudimentary, highly basic, but does well to get the point across about scanner, right? And every time I run this, then I can do something completely different, right? It's not hard coded. So I can say 7 and 13. Now, in general, for our purposes, we don't really have to worry about closing scanner. Right, if we look here, we might look at it, we can look at the little yellow squiggle here under I, and it'll tell us that scanner is open, but it is never closed. And that is in general, or can be in general, a resource leak. Now, with where we're at in the terms of the programs that we are running at this point, we don't really have to worry about it. Right? Because our replit is going to run, it's going to do its thing, and then the environment's going to stop, right? Like it runs, and then it stops, it shuts off. So once it shuts off, everything is cleared out of the memory, so we don't necessarily have to worry about the resource leak. But if we were in some kind of game loop or some kind of infinite loop where it's checking for something every so often, or if something happens, right? It could, over time, build up a memory leak that eventually causes a stack overflow and a crash. So ideally, what we would want to do is we would want to, at some point, just close scanner so it can take everything that was in memory for scanner and get rid of it. And so basically, all we need to do there is just whenever I'm done using scanner, I can add a line that is I.close. Like so. Or whatever we name our scanner, right? Just because that's our I in this case is our object name, so we'd use our object name here. So in this case, it's I.close. It could be N.close. It could be input.close. Whatever you chose to name your object. And so now we see that little yellow squiggle under the I is gone. It is closed. It's closed after we need it. Right? If we close it prematurely, that causes problems. Right? If I closed it, for example, here, then it has freed up that place in memory. And so when I get to this reference here, it won't know what I'm talking about, and it'll error out. So it'll be fine for the first one, and then throw an entire fit at the second one. But if I just put it down here where after I'm done, it's going to work the exact same way like it worked before. So, something like 14, 26, 14 plus 26 equals 40. All good. Right, so that gets me a good little demonstration there. So let's talk about a few more things here before we wrap up for today, and maybe do a quick demo. I always forget to turn that off. Even when I want to go back and forth, and I always forget to turn that off. So let's talk a little bit about structure and formatting and different things here. Because I do think it's important, right, to kind of understand how things are working in the background and how the structure is kind of formulated on the background. So as we are developing new things, we can kind of mimic that same structure and do our own thing. And so when we look at it, a program's kind of structured like this. And these are the terms that we use as well. Right, so for something like java.util, in the line java.util.scanner or java.util.system or whatever it is that we're using there, java.util is the package. And another term that we might use for package would be, library kind of works for package. Because inside of this package, you can have different classes. And each of these classes will have different methods. And so that's why we have this sort of weird, all overlapping sort of concentric circle, even though they're not concentric, all overlapping circle Venn diagram here. Because as we go down from big to small, we see that package is our big outer level. That's java.util or whatever that we might be working with. We utilize some different classes that are in different packages in the future. The class being scanner, and again, we said, one of the key ways that we can tell a scanner versus other things that are a part of our program is that our scanner, or rather our class, will always start with an uppercase letter. So it's uppercase S scanner. For the math class, for example, it's uppercase M math, so on and so forth. Right? We'll use a bunch of different classes throughout the semester. And then it's methods, right? And in other programming languages, we might call a method a function, right? It's an encapsulated sequence of instructions or statements that all serve a singular purpose. So we can take them and compose them into a singular method. A statement is just a simple line of code. It's an instruction. An expression is something that is evaluated, like, for example, hour times 60, our variable in this instance times 60. And then finally, our token is an even smaller bit of that. It's just sort of our variable name or other things of that nature, right? Literals. Sometimes you need to use a number as part of a calculation. For example, pi. And so the value is called a literal. And so we could just put the number directly into an equation. But that can be confusing. Right? Because if we don't have anything that sort of gives it a little bit of purpose, then it's just kind of a magic number, right? Like, we don't really know what this number is in context of the equation that it's in. So we'll typically store them inside of variables. And as we'll see on the next slide, we typically store them in a specific type of variable. Because these literals never change, right? They are this sort of magic number that needs to be a part of this equation to get this equation to work. So instead of just putting them in a regular variable, oftentimes we'll take a literal and we'll put it in a constant. And for example, if you're familiar with Python, one of the things that we learned in Python is that Python doesn't really have an actual constant. It has sort of a de facto constant where if you see the name written in all caps, then you know automatically that it's a constant. But it doesn't have anything like Java does here, where I can take the term final and put it before the type in my variable declaration and have that variable become non-iterable. Right, so for example, if we go back to our replit here, right, just to make this stuff clear, I will, drag this down here. And let's go ahead and take a second to kind of just add some comments here to just make this more understandable. That way, when you all are going back and looking at this file later, you know what what these different sections are. And so let's just do a brief example here of what it means to be a constant. Right, so I'm going to just create a variable here. It's going to be a double variable, double pi. And we are going to set that equal to 3.14. Right, and so on its own, that's going to work, right? Like if I system.out.println here and print out the value of pi, it's going to print me out 3.14, right? We all understand that. But there's a lot that goes on in a program, right? So let's just say that maybe by accident, right, maybe I have another variable that's called pi, PIE, or maybe pit, or something that's kind of close that I'm manipulating, and I just come in here and I'm doing it pretty fast, and I go, oh yeah, so yeah, that variable times equals 4 to iterate it. Well, what I've in essence done here is I've reassigned the value of pi, which needs to be a constant for my equations to work correctly. I've reassigned it a new value. So now when I reference pi here, pi is no longer 3.14, pi is now 12.56. So any equation that I'm using pi in is just going to be wrong. And so what I can do is I can just add the word final before double pi there. And we can see it's already kind of throwing a bit of a fit here because we see a red squiggle under the pi here in my reassignment statement. So if I run this, it's going to error out. It's going to throw a big error. Cannot assign a value to final variable pi. Could this work outside math equations? So yeah, right? Like it basically works for the assignment of anything, right? If I want something that's going to remain constant, I put final before it, and then I'm not allowed to change this value at all. I can use it in other equations, right? Like I can say pi times 4.5 or whatever, and my value pi is just going to remain what it is at 3.14 and do its thing. But I'm not allowed to take the value out of pi, right? It's basically like I just took my container that we talked about for our variables, stuck some data inside of it, and then sealed the lid. So I can't take that data out and reassign it and replace it with other data. So I can still use this as a part of math equations. I can still do whatever I want with this variable. I just can't change the value of the variable accidentally. So it's sort of a safeguard that helps protect me. Sure thing. And this, of course, it will also work with strings and anything else, right? Just so I don't accidentally change that value if it becomes possible. And so the other big thing that we typically do in these sorts of cases is that we will make these final variables all caps. And as we can see there, when we make them all caps, it's not really actually doing anything to the variable. It's more of a visual indicator to the developer, to you. When you see, when you're 100 lines further down and you're working on new stuff and you see uppercase pi, you visually know that that's a final variable that you created, and you shouldn't try to reassign it or else it'll break your program. One of the fun things that we kind of mentioned previously but didn't really talk about is this idea that, we have our floats and we have our doubles, and our double is more precise, but sometimes we might want to take that precision and truncate it to, for example, have a two-point decimal number. And so, just in general, right, there are other libraries, there are other classes that exist in Java that do things a little bit differently. But for our purposes, we can use printf instead of printline. Printf stands for print formatted. And this is what we can use to sort of take our variables or our variable output, for example, like our floating point numbers, and round them to 2 decimal places, for example. And it's, it's pretty interesting the way that we kind of work with this. So what I do is I might say, let's head back over. Let's take this example that we're working with here, right? And if I make this a bit longer, we end up with this floating point value, 14.2713. Well, what if we want only a portion of this number? We can use printf. Print or system.out.printf. And again, printf is our formatting. So in printf, I need 2 parameters. I need 2 different bits here that I can work with. And so the first thing I want to do is, in quotes, I want to put the way that I want my number formatted. And this is going to, again, allow me to control the precision. And so I can actually take and put 2 different values in here. One before the decimal and one after the decimal. That will allow me to control both sides of the precision. All right, so I'm going to start out by putting a parenthesis. The parenthesis, or a percent symbol rather. Let me zoom in a little bit here so you all can see this a little bit better. I'm going to start out by putting a percent symbol in here, and that just lets it know that, lets my compiler know that this is a part of the formatting for this particular formatted print string. And I can give it a value. And the first value is going to be the width of the number. And so that's kind of how many places we want it. So if I were to just say, let's put a 5 here, just to do a little bit of testing. And then I could put a decimal point. Let's say I want 2 places after the decimal place. We'll put 2, F, and then %N to signify the end of my formatted print. Now, this is not necessarily something that we need to do, right? Especially as we're learning, right? This is not a requirement. If you want to just have your full number out there without trying to control it, you are welcome to do that. But then we can take this value here, put it after a comma. Whatever we put after the comma is what's going to be fit into our formatted string here. And so now if we run this at this point, we'll see an unformatted string and we'll see a formatted string. So we can see our unformatted is 14.2713. Our formatted is 14.27. If we were to, in this instance, if we were to kind of take and make that width smaller, make it a 1, it doesn't really matter. Right? What's having the most impact on this number is what comes after the decimal point. And so if I put even more numbers here, like if I put 8, it's going to add zeros after the decimal so that it goes to 8 places of precision, right? So in this case, it is 0.271300000. So you have 8 places past the decimal. And I think even for all intents and purposes, I could do I think maybe I can just make that an F.8FN and that would work. No, that's something different. But I think maybe a 0 would work. No, that won't work. So I think it at least has to be a 1. Your printf is something that you'd probably also want to bring up the documentation for while you were working with it, just to make sure that you got your little string here correct. But we can see the difference between precision here. Another thing to note, right, is if I were to say 1 place after the decimal, we see that it does round for me. So without rounding to 1 decimal place, it's 14.2713. If I print formatted, it rounds for me and gives me 14.3. Especially where we're at right now, a common thing for this would be to use it with money, right? So you always have 2 decimal places for money, although you do lose precision to rounding errors if you are if you're dealing with money in this sort of way. There are other ways that we can deal with money, but within the scope of where we're at for this course, it is not really something that we need to worry about. I guess one final thing to kind of point out here is that we can, ideally, most of the time, right, this is a variable name. So we can put, say, 00, equals the result of this equation. And then we can just stick O in there. And it's the exact same thing, right? So let's see here. I do have a coding challenge that we would normally do here. And I can do it quickly. So I might just do it just really quickly here. Because it is just simply, it's a really basic GPA calculator that we're talking about here. And so if this is something that you want to try on your own, I recommend you all doing it. Right? If you're watching the recording, I recommend you pausing the video, right? If we were in a seated class together, this is something that I would give you as a challenge, let you work on it for a little while, and then we'd all come back together and see how we did. And actually write a program together that works. So, if you're here with me live, I recommend maybe going back and trying it out later. If you're watching the recording, I recommend maybe pausing after we talk about the prompt here in just a second. And working on it and then coming back. But the prompt is thus: Sarah takes 4 classes each semester. She wants a program where she can enter the grade point from each course and get her grade point average for the semester. So let's create a program where Sarah can enter 4 decimal numbers and receive the average. So here's what I'll do, especially for the benefit of those who are here with me, if you want to try this on your own later on, for example. This will be the work file that I post when I post the recording. I'll make a new Java replit here. That'll be for the GPA coding challenge that I won't give you, so then you can actually try it out on your own and see how things work out. So here's what we're going to do here. And I'm going to do this relatively quickly since we are pretty late on time here. So the first thing I want to do is I want to just delete that output, delete the boilerplate line there, that system.out.print line hello world. I don't need it. I'm going to use a printf for this one anyway. And so the first thing that I want to be able to do is I want to be able to get 4 grade points. All right, so in order to do that, I need a scanner. So I'm going to import java.util.scanner. Right, so now it knows what I'm talking about when I'm talking about scanner. And I'm going to create my new scanner object. So scanner in equals new scanner on system.in. And so remember last time we called our scanner I. This time we're calling our scanner in. We can take whatever this word is right here, and we can make it whatever we want it to be. We can call it lemon if we want to. Right, but typically you'll see it called in or I. And so now the next thing that I want to do basically the same thing 4 times, just slightly changed. All right, so I want the system.out.print grade point 1 colon space. And then we'll create a double variable for GP1 that will house the result of n.next double in this instance. Since we are getting doubles, right? We're putting it in a double variable. We're getting doubles. We said we use n.nextInt for integers, n.nextLine for strings, n.next double for doubles. And then we basically take this same thing and we do it again for each of the other grade points. Just changing a few things here, right? So that's grade point 1. This is grade point 2. So I'd change my variable name to GP2. Grade point 3. My variable name here is GP3. Grade point 4. My variable name here is GP4. And so note, right, remember that I only need one scanner object for the entire program, right? I don't need to make multiple scanner objects. I can keep using the same one over and over again because I'm going to get a different stream of data from the system each time. And I'm just putting it inside the variable. So now if I want to, I can close my scanner with n.close because I'm done using it now, right? When I take this last double, I'm done using it. And then one of the things that I might want to do here is just create another variable, double, GPA, that's going to hold the calculation value. So to have your average GPA, you just take and you add the values together and then divide by the number of values that are present. So this would be GP1 plus GP2 plus GP3 plus GP4 divided by 4. Now in this instance, we set it up. We made it a little bit easy for ourselves. In the future, we'll talk about how we might do something like this if we don't know how many we're going to start with. Right? In this case, we know how many we're going to start with, so we can just kind of work with what we know and work within a system. In the future, we can work more on if we don't know how many we're going to have. And so that value is there. So now in our output, we can system.out.printf. And so we just put in our string here. This semester's GPA, colon space. And here is where I can add my string or my my pattern for my formatting. So it's percent symbol 1.2 percent n, and then comma the value that we want to put in that location, which would be GPA. So now I can ensure my GPA is always 2 digits, right? It's always going to be 2 digits after the decimal. Right, so if we run this now, we get grade point 1. Maybe Sarah made an A in her first class, or she got a 4.0. Maybe she didn't do so well in her second class. Maybe she made like a C plus or somewhere around there. Maybe she got like a 2.5. In her third class, maybe she got a B at a 3.0. And maybe she got a B plus in her fifth class. So maybe we could say 3.5. And oops, what did we do wrong here? Illegal format precision exception. Let me make sure that I formatted that correctly. You know what? I forgot I forgot the F. There needs to be an F right here before that percent symbol. Because it's 0.2 formatted. So now we can do it again. 4.0, 2.5, 3.0, 3.5 gives us a 3.25 for the semester. And in this instance, we don't really need to do the printf here because it's always going to be a nicely, evenish number like that, since we're using whole numbers and like 0.5s. But whatever works for us, right? So there is that. And so that basically solves that problem of our coding challenge. You'll get the other file. You won't get this one because I'm going to leave that one for you to kind of work through on your own. So that's all that I have for you for today. We'll go ahead and take any questions if anybody has them. We've definitely cruised past our hour mark, but not too far here. If you're watching the recording and you have any questions, send me an email, send me a Teams message, let me know as to what your questions are. We saw 3 really good examples today of using different methods in our scanner class to pull different values in. Right, we saw next line, we saw next int, we saw next double. And these are basically the 3 that you're going to need basically forever, right? So we're good as far as all that goes. We'll turn the music. Not seeing any questions right offhand, so we'll turn on the music again for just a minute, and I'll hang out in the chat for a couple minutes just in case anybody who's here with me live, thinks of a question. If you think of a question later, email Teams message, right? But that's all that I have for you for today. Thank you for watching. We'll see you next time.